So let's talk about RAM. And what is RAM? RAM means random access memory. It's the computer hot memory. It's very different from disk, which is the computer cold memory. So many people, when they talk about memory, they confuse RAM and disk. It's very, very different. So RAM is basically a speed up in a computer. It's super fast, but it is very expensive, very fast, and it's often used by your computer to cache objects, to cache a lot of stuff, to access it very quickly. The RAM gets totally emptied and lost every time your machine reboots. So that's why it is called a hot memory or a cache, because it doesn't persist. If you want to persist data over time, over reboots, you have to put it into the disk. The RAM is just hot memory. So when is the RAM used? Basically, anytime your application will store data in memory, the RAM will be used. So, for example, a small amount of RAM is used by the OS and the running applications. There's the top command, and I'll show it to you very soon, to find the current amount of RAM being used. And, to give you examples, concrete ones, for example, Apache Spark, which is a big data framework, does a lot of in-memory computation, so it requires a lot of RAM. If the RAM is not enough, usually you get these kind of errors. You get an out-of-memory error, or the RAM will do something called swapping, which says it will extend to disk and extend its size to disk. But because the disk is way slower, you experience a huge slowdown, okay? So good to know, when it's swapping, performance will degrade considerably. So now let's go through examples just to pick your curiosity and really make you understand when is RAM used and when is not RAM used. Now say we create an application, and that application is meant to remember the entire English dictionary and find definitions for words very quickly. So someone may come in and say, I want to know what castle means, and the application looks up what castle means. Now your dictionary, the whole thing lives on your disk, but when your application starts, it will be loaded in RAM, okay? So the English dictionary is so big, you may need a lot of RAM, maybe a few gigabytes or tens of gigabytes, because the English dictionary is big. So, but thanks to your dictionary being in the RAM, now when your application will look up a word, it'll be very quick, because it'll be all in memory, all accessible very quick. So in this application, that's pretty simple and pretty dumb, increasing the amount of RAM for this application will help only if the dictionary gets bigger, okay? If you have too small of a RAM, the dictionary cannot fit in the RAM, you'll get an out-of-memory error. And if the dictionary gets bigger over time, you will need more RAM over time. So this is a really good use case into showing when is RAM used. Now, oppositely, let's say your application needs to compute the value of pi, and pi is 3.14, etc., etc., with a lot of precision. Now, the formula of pi does not require the computer to load anything in memory. It's just a mathematical formula. It's just computations, right? So there is a formula to get it iteratively, and because you only care about the last result, all the others being discarded, nothing is kept in memory but the last result, which is very, very little amount of RAM. In this case, as I said, no RAM or very little will be used. So for this application, if you increase the RAM when you run it, it will have zero effects. So that's very, very common. I see some people saying, hey, let's increase RAM and everything will be better. No. Based on what your application does, for example, if it computes pi with a lot of precision, RAM will be completely useless. Now in EC2, what does RAM look like? Some EC2 machines come with a lot amount of RAM for cheap, and they're called the R generation. So at the time of recording, it's R4. Or if you have a lot of money, there's X1E. You should use them only if your application requires a lot of memory, and we've seen kind of use cases where application requires memory and when it doesn't. So here's an example from EC2.info where I compare the R4 to the X1 to the X1E large. And so as you can see, the R4 high memory extra large, so R4.X large, has 30.5 gigabytes of memory. So that's a lot. And if you go to a crazy amount of memory, you can get the X1E large, 16x large, and that one is almost a terabyte of memory. Now, if you look at the Linux on-demand cost, it's very expensive, okay? So more RAM means more money, but these kind of instances, R and X1, give you the best price point for the amount of RAM they provide. So let's just run a few commands. I'll show you what RAM looks like in our EC2 machine, and we'll monitor RAM and figure things out, okay? So let's get started. So I am in EC2 and I just started a machine. So here's my public IP. And again, if I go to public IP 4567, I should be able to see my hello world. So my application is working. Now if I go to /ram/info, it will give us RAM information. Right now there is a total free memory of almost 700 megabytes. Okay, so let's go ahead and SSH into that machine just to get a better idea what's going on. So I'll just replace the IP at the very end. Oops, you need to remove the HTTP, just put the IP. So here we go. All right, we're in. So yes, and here we go. So this is our machine. And I said there was a first command called free-m. And free-m gives you the total memory for your machine, how much is currently used, and how much is free. So there's a concept of cached, which is called page cache. Really, if you want to look at exactly how much your machine has, you want to look at the second one. So 81 megabyte is used by the instance right now, and 912 is free, okay, or 786, best if you take into account the cache memory. Anyway, so as you can see, there's some amount of memory. Now, if I go back to my app and just use /ram a couple times, what this will do is that our application will start loading stuff in memory. As you can see, the total free memory goes down. So let's go back to free-m and run this command again. And as you can see, now the amount of used memory is 288 and the free memory is 705. So we've basically put more stuff in memory and it's starting to use more space. Now, if I keep on doing this, it will keep on loading the memory and my application will keep on loading up the memory. And again, if we do free-m, now we see we're using 424. So you can have fun and play with it, but this gives you an idea of how much memory is used in your computer. Now, if you do alternatively the top command, top gives you an idea of all the processes running on your machine and including their CPU and their memory usage. Now, once you're on top, you do Shift F and then you do N, and basically this will sort everything by memory. Enter. And now we can see that our Java application right here is using 38.7% of the memory. So if I keep on running this command, like you hit that URL by clicking on refresh, we can see that now we jump to 46.7% of memory. Okay, so very important, just to give you an idea of how RAM can be monitored. Right here, right now we have 54%. And again, if you wanted to clean the RAM, you do RAM clean, and this should free up the amount of RAM available for your machine. So what I wanted to show you here through these commands is that you can use the free and the top, so the free command right here, and you can use the top command to basically monitor your memory over time and figure out whether or not your instance is using a lot of memory. And that's very important when you start sizing your instance and when you start choosing, oh, it seems like my application is using a lot of memory, I need to increase it and move towards a R type of instance. Okay, so hope that was helpful for the memory, and I will see you in the next lecture for CPU.